Hey guys, so today we are going to be focusing on equations with variables on both sides. We're going to focus on that in this video and the next one. This one is going to be variables on both sides, decimals and fractions. The next one is going to also have parentheses and distributive property. So, the learning goal. This is learning goal 8-6. This is actually from your guys' notebook. So as you can see, we did this back in September, but we have to review this because you guys got to know how to do this going into 8th grade. Analyze and solve linear equations. So, linear. What does linear mean? It literally has the word line. Okay, so equations that graph as a line. Oops, you can't see it. Therefore, if they graph as a line, the variable just has an exponent of 1. We're not going to have like x squared or anything. Graphs as a line. As soon as you guys think of line, you guys should immediately think y equals mx plus b. Not that that's what we're focusing on, but as soon as I see linear equation, that's the linear equation that should come to mind. Now, we're going to be level 3 by the end of this because we need to master this. So that is our goal. We're going to be solving multi-step equations. So we're going to have a lot of steps with variables on both sides. Okay? Including any combination of combining like terms. So we're going to have to combine like terms, things with variables and things without variables, constants, and using distributive property, which we're going to be getting more into in the next video. So that is what we are focusing on. Mainly solving multi-step linear equations in one variable. It's not like we're going to have x's and m's and q's in the same equation by combining like terms. Tomorrow, the next video, we're going to get into distributive property. So let's get started. I made a trail mix and I saved you guys one of my heart Cheerios because I genuinely miss you guys. I've thought about each and every one of you as I go through the class roster and put grades in and see who's done their stuff and who hasn't. And I love you. So now you can listen to me as I crunch on this Cheerio. Alright, so our first equation that we are going to solve. 3x plus 5 equals 2 plus 4x. So I know that when we did these, you guys struggled the most when we had variables on both sides. That's why we're revisiting it. So first we lock up the variable. And in these equations right now, you're always going to see just one variable, like the same variable. It's not going to have different letters. Draw the line. So we can see that on one side, I'm going to put the brightness down. We can see that on one side of this equation, on one side of the equal sign, we have the coefficient with the variable and the constant. On the other side, we have the constant, the number without the variable, and then the coefficient with the variable. We need to get the whole numbers on one side and the x's on the other side. It does not matter which side you take to which. It will still get you the same answer. I like to keep my x's positive. 4 x's is more than 3 x's. So I'm going to take this 3x and get it over on this side. So how do I get a positive 3x to the right? Well, the opposite of positive 3x is negative or minus 3x. If I have 3 x's and then I take them away, I subtract them, we're left with none. What we do to one side, we do to the other side. So minus 3x, minus 3x. That leaves us with a positive 5 on this side, so we just bring it straight down. Equal sign. 2, just bring it down. Now 4x minus 3x. So we have 4 x's, and then we take 3 of them away. That leaves us with 1x. You can write the 1 in front of the x. You don't have to. If you don't write it, you just know there's one x there. Now it's just a one-step equation. Okay, I'm going to box it up again. So we need to get x by itself. We need to get this positive 2 over here. So how do we get this positive 2 over there? Well, we have to get rid of it on this side, so we need to subtract it. It goes away. What we do to one side, we do to the other. Subtract 2. 5 minus 2 is 3. And then we bring down our x. So x equals 3. And that's the answer. If you wanted to check it, you could always plug it back in. So 3 times x, 3 times 3, 9, plus 5. 9 plus 5 is 14. So this side equals 14. This side, 2 plus 4 times 3. 4 times 3 is 12, plus 2 is 14. 14 equals 14. All right, number 2. .6 plus 4w equals 9.6 plus 8w. Don't let the decimal scare you guys. They're just, oh my goodness, for a second I thought this wasn't recording. They're just numbers. They just have decimals. It's okay. You guys get your calculators. Like, they're not scary. Draw your line and box up the variable. We better have w on both sides. Yep. All right, so now we get the w's on one side and the whole numbers, the constants, on the other. So, and I understand these aren't whole numbers, they have decimals. You guys know what I mean. So get this 4w over here. First step is get the variables on one side. But Ms. Fry, what if we wanted to get the 8w on the left side? That's fine. You'll still get the same answer in the end. I just like to keep my variables positive. So 12.6 stays. We bring it down. 4w minus 4w is nothing. Equal sign. Bring down the 9.6. 8w minus 4w. So if we have 8 w's and we take away 4, that leaves us with 4w. All right, think about what you would do next. Now it's a two-step equation. All right, we got to get this 4w by itself. So get this 9.6 over here. How? Well, it's positive right now. So we have to subtract it, take it away. Gets rid of it. What we do to one side, we have to do to the other side. You guys are more than welcome to use your calculators. 12.6 minus 9.6, I lined up my decimals when you add or subtract with decimals. 6 minus 6, 0. 12 minus 9 is 3. So 3.0 equals 4w. That's the same as 3 equals 4w. So I'm just going to rewrite it because I don't like the 0.0. All right, so what is our last step? We don't have w by itself yet. The 4 and the w are touching. They're married. We have to divide. We have to undo that marriage, undo the multiplication. Divide by 4, it goes away. What we do to one side, you have to do to the other side. So that leaves us with w equals 3/4. Yes, it's okay if you put w equals 0.75 because 3 out of 4 quarters is 75 cents. Same thing. So far the two types of problems we've had is combining like terms by getting the variables on one side with the coefficient and then the constants on the other side. Sometimes though, we're going to have problems where we need to combine like terms on one side of the equal sign. Here, you'll see in the next problem. So negative 3 plus 6m plus 5 equals 11 minus 3m. Immediately draw the line down the equal sign. That separates your equation, because equations have to have equal signs. Equation, equal sign. That separates your equation into two expressions. Expressions don't have equal signs. So now just look at the left side. Is there anything that we can combine right off the bat? Yes, the negative 3 and the 5. Why can we combine the negative 3 and the 5? Because they're constants. They don't have variables. 6m has a variable. You cannot combine that by adding or subtracting. But the negative 3 and that positive 5, neither one has a variable. We can put them together. So negative 3 plus 5. So we're 3 feet below ground, and then we climb up 5 feet. That leaves us 2 feet above ground, positive 2. And then we just bring down the plus 6m. Okay. Now we look at the right side. Is there anything that we can combine? No. 11 doesn't have a variable. The negative 3 does. So we cannot combine them. They're unlike terms. They are not like terms. So we just write it. Now, why did I write the 2 and the 11 purple and the 6m and negative 3m light blue? Those are our like terms. Like terms means we can combine them. Okay, they're alike. Both have variables, coefficient, variable. Both constants, no variable. It does not matter which side you get the variables to and which side you get the constants to, as long as they're on opposite sides of the equal sign. So I'm going to, because I always try to keep the variable positive. What I mean by that is if I add 3m, it goes away here. And over here, it keeps it a positive m. It'll be positive 9. If I did it the other way, which you totally could, you would subtract 6m, because it's positive, subtract 6m, but then it'd be negative 9m, and I don't like playing with negatives if I don't have to, so that's just why I do it that way. But guys, you'll get the same answer either way. So that leaves us with 9m. Why I changed my pen color, I don't know. I was just getting bored. Bring down the 11. Bring down the 2. 2 plus 9m equals 11. So now it's just a two-step equation again. This is what we mastered last week, hopefully. Fingers crossed. I'm filming this during the first week of distance learning, but so far you guys have been doing pretty well. So, locked up the variable, continued my line. Okay, we have to get the constants together. Right now that's a positive 2. How do we get rid of a positive 2? Subtract it. 2 minus 2, bye-bye. What we do to one side, we do to the other. So that leaves us with this positive 9m on this side. 11 minus 2 is 9. So 9 times some number equals 9. Well, we know the answer is 1. 9 times, so we have to undo that multiplication with division. 9 divided by 9 is 1, so it leaves us with 1m. We're lazy, we don't write the 1 out front of m. What we do to one side, you have to do to the other. I know it's tempting just to bring the 9 down, but you have to divide it by 9 first. You can't just get rid of it here and not do it to the other side. 9 divided by 9 is 1. So m equals 1. All right, let me turn the page. 4. So you would have to combine the like terms, regardless if they're numbers like constants or if they have variables. You have to combine them on each side of the equal sign before you keep moving. That's the fastest and most efficient way. So that's why I say right off the bat, immediately, the first step, you always draw your line and box the variables. When you box the variables, it helps you see where are our like terms. Like terms will have the locks around them, the variables. The other like terms will not have the variables. So then we look at each side, the left side. Can we combine this? No. 6f, 11, unlike terms. Right side. Oh snap. We have two coefficients with variables. We have negative 5f's, and then we add 8f's. So if I have negative 5f's, and then someone gives me 8 of them, I have 3f's. Bring down the plus 7, equal sign. So we already handled that. Bring down the plus 7. Left side, we didn't combine anything, so we just rewrite it. Our 6f's and our positive 11. So now, we cannot combine anything on each side. So now we have to get the f's to one side and the constants to the other. So, immediately I see, take the 3f over here, because 6f is bigger. 6 is bigger than 3. I like to keep it positive. 3 minus 3f's goes away. Leaves us with nothing. What we do to one side, we do to the other. So subtract 3f from both sides. 6f's, take away 3f's, leaves us with 3f's still. Bring down the plus 11, the equal sign, and the plus 7. You don't have to write that plus sign. Now it's a two-step equation. We still have our line drawn. I box up the variable just to organize it. So we need to get this positive 11 over there. Minus 11. 11 minus 11, it goes away. What we do to one side, we do to the other. Minus 11. That leaves us with bring down the 3f. Bring down the line and the equal sign. 7 minus 11, negative 4. Are we done? No, we have to get f by itself. They're touching, they're being multiplied. We have to divide. Divide both sides by 3. So f equals negative 4/3. That's a fraction greater than 1. Leave it like that. We like that. Yes, it is correct if you say negative 1 and 1/3 also. All right, the last one I'm going to do is just going to have fractions in it. And then I think you guys are good to go. That's every single type that you'll be seeing on Khan Academy, and those are the levels that I want you to know for this lesson. I'm just trying to pick which one I want to give you. Let's do this one. 2 minus 1/2 n equals 3n plus 16. Immediately lock up the variable. Can't touch it. It's in a box. Draw the line. Can't touch this. All right, we got to get the variables to one side. I'm going to take this negative half n over there. You have to know this minus, this negative sign is attached to it. You have to do the opposite of it. So add half n. Negative 1/2 n plus a half n goes away. It just leaves us with this positive 2 down here. What we add to one side, we have to add to the other. So we're adding a 1/2 n to both sides. You can write it as 3 plus a half. That is 3.5 n. If you're comfortable with that, you can do it as 3.5 n because 1/2 is just 0.5, like 50 cents. Or you can do 2 times 3 is 6. 2 times 3 is 6. Plus one more is 7 over, you leave the denominator, the 2, n. whichever one you prefer. I prefer the fraction greater than 1. 3.5n is fine. 3.5n is fine too. Actually, yeah, let's do that. 7 over 2n. You'll get the same answer no matter which way you do it. Plus 16, because we just bring that right down. Lock up my variable so I don't forget about it. All right, now I got to get my constants to one side. Bring this positive 16 over to the left. Well, how do I undo adding 16? You subtract it. 16 minus 16, it goes away. What we do to one side, we do to the other. So 2 minus 16, or negative 16 plus 2, is negative 14 equals 7 over 2n. All right, this might be when you guys would have preferred to have 3.5n, but that's okay. The 7.2 and the n are touching. They are being multiplied. I know it's a fraction, but they're still being multiplied. There's invisible parentheses around them being multiplied. How do we undo multiplication? You divide. Divide by 7 over 2. Okay, 7 over 2 divided by 7 over 2 cancels out to 1, leaves us with an n. What we do to one side, we do to the other. Divide by 7 over 2. You can keep, change, flip, or you can just use your calculator. I need to grab my calculator, I forgot. All right, so negative 14 divided by 7 halves. So 14 negative, the fraction bar means divide, by 7 over 2. 7 ABC 2. And I know Khan Academy gives you guys a calculator. Negative 4. So n is negative 4. So after doing this, and after doing your Khan Academy, you guys will have solved many problems, many multi-step linear equations. All of these variables had an exponent of 1. Because no number was ever written like a 2 or a 3. So you were solving multi-step linear equations with one variable. They always had one letter per problem, and we were combining like terms. Okay, guys, this is challenging stuff. Practice, take your time. Email me, text me, call me with your questions. You're not bothering me. And then in the next video, we're going to get into distributive property.